Now, waste management is a big menace. People don't pay much attention to it. When we have some unused mobile phone or charger, or for that matter, any electronic, for example, some scrap computer, laptop, or any other computing device, uh, then there are many environmental hazards related to it. Many of people don't know that there are heavy metals, there are poisonous chemicals in batteries, and they may be explosive also. So there has to be a lot of awareness related to e-waste management. Last year we did a study in our municipality here in Bihar, and we found that there is no way of e-waste management. People just dump in dustbins, and then it is burnt along with other kind of waste, solid waste. That is very dangerous, because when you burn this, when you put this on fire, a lot of hazardous fumes, and this thing will be there in the environment. A lot of problems will be there. It can be dangerous, very damaging to the environment. So, in green technology, in green IT in particular, because your usage of ICT results in a lot of e-waste on regular basis, a lot of e-waste. So, this is an issue that that should be paid heed to e-waste management. If you are thinking about sustainable use of ICT, then you must work on policies within your organization, within your community about electronic waste management. These are some of the references that I have used, some that I have used some matter from there. For example, there is this United Nations website. There, this Sustainable Development Goal is given. There is this paper, a total energy consumption of the ICT in between different components. This is by Stephen Lange I referred to. There is Green Harvard page and Intelcom page. Now I have this favorite author E.F. Schumacher, who wrote a very good book. He is author of Small is Beautiful. If you remember, in the very beginning of this presentation, I said something about bigger is not always better. And then there is this book, Small is Beautiful. This is the message of this book, that wisdom demands a new orientation of science and technology toward the organic, the gentle, the elegant, and beautiful. Now we demand a new orientation of science and technology. That is, we need a complete paradigm shift. In the last century, what happened is we were we were behind progress, and we thought that progress means more and more manufacturing units, factories, lot of production, and lot of work. But now we have started to realize that it is causing damage to the environment. We are having acid rains, we are having ozone layer depletion, we are having many such environmental issues. Recently, during this Chhat festival in Delhi, we all saw pictures of froth in the Yamuna River, and we all see damage to our environment everywhere. In Rajasthan, also you can see such examples. There is a lot of depletion of groundwater. There is a lot of contamination due to industrial units. So wisdom demands a new orientation of science and technology. We have to be less aggressive. We should care about the organic, the gentle, the elegant, and the beautiful. I will recommend all of you to read this book by E.F. Schumacher. And before we go further, you may ask any question if it is related to our discussion. If there is any query or if any input is there, I would like my audience to please ask their questions one by one, and then we will go further. I can't hear anybody. Is there any question? If somebody is interested to ask any question, you may ask, so that I know that you are actually, attending the session and are actually in the content.
Hello.
Hello.
Sir, everyone is attending your session.
Mhm.
And if they have any query, they
Mhm.
can raise hand, they can write in chat box, they can directly ask you the question. So please, no need to wait. At the end of the session, you give the 2 minutes for any query. If they ask, then you
All right.
solve
So,
them.
can
Otherwise,
I
you
ask?
are.
Sorry to interrupt. Can I have an idea how much time is left for completing this?
Yes, 2 hour, 2 hour.
So we will be going up to 2 p.m.
Yes.
Okay. No, but I don't see any I don't like when it is just a one-way broadcast. I have a lot of matter, but let me see what is the impact on my audience. Whether they are following or not, what is
No,
their
no, no. They are they are very used to listen to our sessions. You know? So you please keep it continue.
all right.
If they have any type of query, they will ask. They can raise hand. They can write in chat box. You know? So please you carry on, sir.
All right. So I just come back on this and then we will continue. Just a minute. So if possible, can we have a 5 minute break? Then we will assemble again. Is it possible?
Break. There is no break, sir. But if you need 2 minutes, then you may
Yeah,
take 2 minutes. Otherwise,
I
don't disconnect. Don't disconnect your system.
okay,
You may
okay.
take 2 minutes, but don't
Because
disconnect your
I
system.
and I have to attend something extremely important. So I need a just 5 minute break.
Yes, if you have any call, please mute it and then can attend. Okay, audio video you can off, then you can attend, sir. Please continue your lecture.
Well, I am back in the lecture and let us.
Yes, please continue. Please continue, sir. Please.
All right. So, friends, now that you have a basic idea of what do we mean by green technology, uh, we have to delve deeper into how can how can we in our organizations minimize this demand for energy and how we can make green IT more effective. That is so e-waste management is one thing that I already discussed. E-waste management This is what you call IT energy management. That is in your organization, in your workplace, how to manage the usage of energy. This is known as IT energy management. Now, it has two parts: analysis and management of energy demand within your ICT organization. These are two parts, I repeat: analysis and management. So, first of all, you should have an idea of how much energy is actually being used in your, what you call your cyberspace, what you call your ICT workspace. Now, it can be anything. For example, you have different computing devices, you have peripheral devices like you have printers, and you have other. So, it is not necessarily just computers, it is everything related to your ICT, information and communication technology. It is also your storage devices, your servers, your workstations, your data centers, routers, switches, gateway, everything that is there, your mobile phones, their chargers. So, first part or the first phase when you try to make it more energy efficient is the analysis of the usage. You have to collect data. You have to find out what is the usage. Now this becomes quite interdisciplinary because computer science people are normally educated and have more interest in softwares, in building programs and applications. But now this is more about what you can say electrical engineering or physics actually, where you know about, for example, if uh, what power is consumed. In fact, I have interacted with many computer engineers who don't even. I once there was in Viva, and I asked somebody, a student, and she was not even aware about what is the difference between the between power and energy. She didn't know that, you know. So that is very important to know about the, for example, what is the voltage that is used in home appliances in computers. Many people don't know that it is 220 volts that is there in India in electricity. Is a range to 20 to 40 volt, and that our home electricity is working on 50 hertz of frequency that is there. In many different countries there are different regulations, so frequency and voltage levels may differ also, and there is this transmission. So one should have a basic idea of electricity and power. They should know how electricity is generated. There are, so we are taught actually in basic electrical engineering, and in physics also we are taught about generation and distribution and utilization of energy. So that is there, some basic idea is there, but we should know. So a few years ago, we one of my BTech students group, I assigned them a project to find out the carbon footprint of the university where I was earlier working, and we did a study, and through our study we found that most of the energy usage was due to switched on lights. Now that is very interesting. In fact, in our university where I am currently working, one of the departments during pandemic, its electricity bills and its power backup. We are using power backup there, so diesel usage was continuously high even during pandemic when the department was closed. So it was found out that during that closure also, the labs, the power, everything, lights, fights, everything was running. So that is very important to understand that. So that is first part. So we found out that okay, because we are continuously switching it on now, then the people who were responsible, they told that they didn't have any instructions to switch off. So this is extremely important. In our organizational policy, in our IT policy, we should have certain rules regarding, for example, if we are having a computer laboratory, so students should be, and who is the lab in charge, they should be instructed, they should know that whenever lab work systems are not in use, they should be switched off. And in fact, even while using your computers or your mobile phones, there are ways to to minimize their power consumption. For example, we can use screensavers. We can use, there are power saving modes also now available in mobile phones. When because uh, and there are certain applications which are very power intensive. For example, Bluetooth. If you keep Bluetooth and Wi-Fi on your mobile phone, then your battery will be depleted very soon, because Bluetooth is very power. Their efficiency. So as I said, 23% of your power, your energy used in this data center. So you should pay attention. Second part is PC power management, because there are personal computers which also use. In a study in US, it was found that 50% of PCs are left on overnight, and it resulted in an annual energy wastage of 28.8 billion kWh, kilowatt hours, around $2.8 billion per year. This is a huge amount. Just by leaving your computers, PCs switched on during night, it resulted in this much of loss. So you just imagine the scale at which energy is wasted. If you don't, that's why, if you remember the 5 tips that were there in the Harvard paper for saving energy, the 5 tips, one of the tips was to switch off your computer. So this is one practical advice. When not in use, you switch off your computer. There are other issues also. There are some proprietary and otherwise available power management software also, which although there is some built-in facility of power management in Windows operating system itself, there are different power modes also. You might have seen in that in your computer also you have various modes like sleep mode and such modes, power saving modes are there in mobile phones also. There are such power saving modes. So these are built-in power optimization ways of your operating system. But there are other proprietary power management software also available, third-party software available, which for some small cost, such third-party software will allow you to manage and minimize your uses of power. And now you have seen the uses of star rating of home appliances. For example, in case of air conditioners, you might have seen that 3-star, 4-star ACs. So different power ratings are there. So such ratings are there. Then there is a interesting concept of what you call energy efficient Ethernet. There is a IEEE standard IEEE 802.3AZ, which is for energy efficient Ethernet. We all are aware about the Ethernet local network. So this IEEE standard is what you call energy efficient Ethernet. And if you use this standard or energy efficient Ethernet, it will reduce your energy use of your networking equipment. In 2005, one study says that all the network interface controllers in the US used an estimated 5.3 terawatt hours of electricity. And energy efficient, one study found that energy efficient Ethernet could save an estimated $450 million of year in energy costs. So this study was only about the United States. If you take it on global scale, or if you think in terms of India, we can also think of using this energy efficient Ethernet. This is a good idea. So I would like to revise the few points. First is server and data center management, which was around 23% of your uses of data. Then came the PC management. The important lesson or takeaway was to switch off the computers when not in use. And third thing which I have highlighted is your energy efficient Ethernet. That is one way of doing it. Then your organization and resources for IT management is there are many different industry associations also and policy organizations who are working on promoting energy efficient standards, including IT energy management. For example, there is this what you call the green grid there is Alliance to Save Energy, there is Climate Savers Computing Initiative, there is 2 degrees. If you know about the Green Grid Alliance, now this Green Grid Alliance, what they are doing is it is a non-profit industry consortium of end users, policymakers, technology providers, facility architects, and utility companies collaborating to improve the resource efficiency of data centers. There were around 175 member companies, and now what is their role? In 2006, when it was initially announced, the Green Grid Consortium was announced. It included members like HP, IBM, Sun Microsystems, Dell, etc. Later on, Intel and Microsoft also joined them. And in March 2011, the Green Grid proposed a new sustainability metric, water usage effectiveness, which attempts to take into account the amount of water used by data centers in their cooling systems. That is also one way of looking at things, because what is sometimes obvious is not the only thing that you have to think about. For example, we all pay attention to use of electricity, how much electricity is consumed by computers, data centers, or servers. But in this particular initiative of the Green Grid, they also analyze the use of water in the cooling systems of data centers. So leave aside small data centers, there are very large, very huge data centers which are used by companies like Amazon or by Google. They are having extremely large data centers. And as I told you earlier, there is heat dissipation issue, so a lot of cooling is required. Now that cooling, air conditioning also uses different liquids, including water. So then now Cisco, Dell, EMC, HP, IBM, Schneider, Siemens, many such companies have become member of the Green Grid Alliance. So there is this concept of what you call power usage effectiveness. That is important. If you are interested in minimizing your energy use, there is this metric what you call power usage effectiveness. What is power usage effectiveness? It is a ratio that describes how efficiently a computer data center uses energy. Specifically, how much energy is used by the computing equipment in contrast to cooling and other overhead that supports the equipment. So PUE, we call it PUE, power usage effectiveness. So PUE is a ratio of total amount of energy used by a computer data center facility to the energy delivered to the computing equipment. For example, if your suppose you are using 10 watt of power, 10 watt of power is used by your computer, and 2 watt is actually utilized by actual amount of power that is used by your center, then 2 by 10, that is 0.2, is the PUE or the power usage effectiveness ratio. There is a formula. PUE is equal to total facility energy divided by IT equipment energy. Ideal PUE is 1, okay, but due to some other issues like cooling, lighting, these also require. So PUE, goes down. There are different standards also. There is this ISO IEC 30134 standard, and there are other standards also related to the power usage effectiveness. So there is this criteria of power usage effectiveness. Then there is a Climate Savers Computing Initiative. That is very important. There is an initiative, Climate Savers Computing Initiative, that is also a non-profit group of consumers, businesses, and conservation organizations, which are dedicated to promoting smart technologies that improve power efficiency and reduce energy consumption of computers. It is based in Portland, Oregon, USA, and Climate Savers Computing Initiative later on combined with the Green Grid, and they are continuing to work with their organizations. What is their goal? The goal of the new effort is to reduce greenhouse gas emissions, GHG emissions, and to save energy by setting targets for energy efficient computers and components and promoting the adoption of energy efficient computers and power management tools globally. So, friends, you can look from different angles on the problem. This way of the climate savers computing initiative, they look from the point of view of computer hardware. When you say energy efficient algorithms, you are looking from the point of view of software. And now they are talking about green software also. So there are different possible ways, but it is not, these are not straight, what you call the standalone things. All these things are interrelated because hardware, software, servers, all these are interrelated. And if you try to and you should try to find some comprehensive way by which you achieve overall what you call PUE, overall efficiency. The study that I cited, Stephen et al., in the very beginning, and if you remember, the important insight from that study was that although there are certain ways by which energy demand is reduced by use of ICT, but overall, if you look at the overall picture, the use of ICT results in increased use of energy. That insight is extremely important. So suppose what you are trying to do is you are working on efficient hardware which will use less energy. It may result in overall increase of energy. So all the agencies, all the stakeholders should work in tandem. That is the message. If you remember the example, I said that for online examination and people who are working for the causes of environment, holding conferences and creating a lot of carbon emissions, overall impact. So we have this concept of net carbon impact. What is your net carbon footprint? Whatever efforts you are doing, what are different ways, whether you are using energy efficient algorithm, whether you are trying to minimize the need of cooling, whether you are using energy efficient hardware, or whether you are doing some kind of measures and trying to minimize your energy uses, it should result in overall reduction in the energy uses. That is the important aspect of green IT. When you say green IT, green IT simply does not mean that you will be using more environment friendly products or you will be using less energy. It is not as simple as that. But it is the comprehensive, the complete thing of product designing, process, and everything management in such a way that your overall energy demand is reduced and your overall footprint on the environment, the overall damage that you cause environment is minimized. This is the way. This is the holistic view of way of looking at things. So if I summarize my talk today on the green technology from an ICT perspective, I would like to say that green technology is not a single discipline. I repeat, experts from chemistry, from physics, from maybe electrical engineering, from different disciplines, their expertise is required, and a collective effort is also required. From an ICT perspective, we can say that regardless to popular opinion or regardless of what we normally think, that ICT results in less damage to the environment or maybe less uses of energy, some studies have concluded that sometimes it leads to use of more energy. So we should not think about mindless automation of all the things. Paper-based systems are sometimes better than your online systems. More studies are required on this aspect because during this 2 years of pandemic, we have moved a lot to online examinations, online assessment, online. In fact, today also in this FDP, we are meeting virtually. So we should try to find out how much energy, because otherwise, if actually we would have traveled to say Jaipur, these many experts, and if the participants would have also traveled, so then this travel could have amounted in a lot of energy, lot of carbon footprint. because they would have stayed in hotels. There, lot of electricity would have been consumed, lot of water would have been consumed. They have traveled through maybe bus or by air, whichever way. A lot of greenhouse gases would have been emitted, and now we are conducting it using this virtual your Microsoft Teams. So how much energy is consumed? So you can see clearly that very less energy in if you compare it to the offline mode. So more and more such virtual meetings and more online examinations and more such online things may result in maybe less use of energy. So this is also one way of thinking of green IT, or from an IT perspective, this is the way of green technology. Then we discussed about the different aspects, different ways, starting with the analysis and then going with the management and the different parts of computers which you account for different uses of powers. And we found that 23% around quarter by data centers, then by PCs, by other components. So, friends, in the end, I would like to say that green technology is all about, I go to my quote in the beginning, that it is about thinking that small can also be beautiful, that bigger is not always better, and mindless automation is not needed, and there is a need of different studies which we computer people should also start thinking about energy aspects. Whenever we design algorithms, when we write programs, or when we make hardware systems, we should also think about minimizing the energy while retaining the efficiency. That trade-off is important. If you energy efficient but they are not very effective in dealing the problem, or have very high computational complexity, that may not work. It depends. For systems like wireless sensor networks and rope networks, as I earlier said, there can be much importance of going energy efficient. But there can be systems where energy is not an issue, but rather efficiency. For example, there can be critical real-time applications. For example, your aircraft control systems, or maybe your nuclear control systems, where energy is not an issue, but efficiency is an issue. So that kind of design thinking we should build in our students also, that they start thinking in terms of energy consumption and energy minimization. Then only we will be able to, what we said, the seventh goal of energy efficiency that was highlighted in the 17 SDGs.